Hello, students, and welcome to our June 7th lesson today. We have a do now about how you have changed this year, so I'd love you to respond to that. Our objective will be to review solving quadratic equations by completing the square and by using the quadratic formula. Our assignment will be to complete a page of problems, and I have some extra problems there for you to do for homework, but you do not need to upload this assignment. This is a review. Please, we will complete this page of problems together, and I think it'll jog your memory a bit as you do that. Important, though, I want you to keep a lookout now for those digital quadratic escape room activities. Those are coming soon. And if you finished early, I do have some fun activities at the end of the page here. Okay, so our do now for today. So many things have changed this year. How have you changed? And what things do you view differently? Not how would you do things differently. That's not what we're asking. How has your viewpoint changed? How do you think differently about things this year? I know I have things I think differently about in terms of teaching and presenting lessons. We sure have come a long way. So if you reflect on that, please answer that right there. So let's move on to our review. We already worked on solving by factoring and solving by square roots. And now we're going to talk about completing the square. When we complete the square, the first thing we want to do is get our quadratic in the form of ax squared plus by plus bx, equals c. Okay, so we want to move c over to the left side of the equation. So, which is exactly what we're going to have to do with this first one. So the 65 will go over to the right side. That means it becomes negative. So we will have x squared minus 18x equals negative 65. And now we want to take half of the b value, which is 9, negative 9, and we're going to square it, and negative 9 times negative 9 equals 81, and then we'll add that to both sides. So x squared minus 18x plus 81 equals negative 65. And now we're going to factor let me add my 81 there. There we go. Now we're going to combine the right side, and we're going to factor the left side. And when we factor the left side, we need two numbers that add to negative 18 and multiply to 81. So that would be x minus 9. So that would actually be x minus 9 squared equals negative 65 plus 81 is 16. So now we're going to take the square root of both sides. So x minus 9 squared, the square root of that is x minus 9. The square root of 16 is 4. And when we solve for x, and remember, this is the plus or minus 4. And when we solve for x, x will equal 9 plus or minus 4, which means x equals 5 or 13, because x 9 minus 4 is 5, and 9 plus 4 is 13. So let's do another one. So we have to move 55 over to the right side of the equation, and that will make that negative 52. So we will have x squared plus 16x equals negative 52, because we had to move 55 over. That gave us negative 55 plus the 3 that was already there is negative 52. So half of 16, which would be 8, and we're going to square that, which equals 64, and we're going to add that to each side. So x squared plus 16x plus 64 equals negative 52 plus 64. And when we factor the left side, we need two numbers that add to 16 and multiply to 64, and that would be 8. So when we factor the left side, we have x plus 8 squared equals negative 52 plus 64 equals 12. And we're going to have an irrational answer here. We can think of that 12 as 4 times 3. So we will take the square root. Let's change our color. Take the square root of the left side and the right side. So the square root of the left side is x plus 8. And the square root of the right side, we're going to think of that as the square root of 4 times the square root of 3. So that will be the square root of 4 is 2. And remember, it's plus or minus 2. The square root of 3. And then our final answer will be x equals 8 plus or minus 2 times the square root of 3. And remember, the 8 and the 2 cannot be combined. If we had a denominator here, we could possibly simplify further. For example, if we had a denominator of 2. But when we have this 8 plus or minus 2, those cannot be combined. So that's our final answer set. And our work is done for number 12. Okay, let's work on number 13. First of all, we'll move x to the left side of the equation, which gives us 2x squared plus 8x minus 14. We can factor a 2 out of here, and we factor the 2. We have x squared plus 4x minus equals negative 7. And that's going to make our work a little easier to work with. Our numbers are smaller now. So half of 4 is 2. 2 squared equals 4. Now we'll add 4 to both sides. And we can, for now, ignore this 2. So we've got x squared plus 4x plus 4 equals negative 7 plus 4. And when we factor x squared plus 4x plus 4, we need two numbers that add to 4 and multiply to 4, and that will be 2. So on the left side, we have x plus 2 squared equals negative 3. Now, when we go to take the square root of each side, we find that our work is done because we have a negative integer in the square root, and that means that there is no solution to our problem. Okay, so let's move on to number 14. And the first thing I want to do is rewrite it as 9x squared, and I'm going to move the 18x to the left, so that will be minus 18x equals 40. And the next thing I want to do is simplify this by dividing everything by 9, which leaves me with x squared minus 2x equals 40 divided by 9. And now I need half of negative 2, which is negative 1, squared, which will equal 1, and I'll add that to both sides. X squared minus 2x plus 1 equals 40 over 9 plus 1. And let's convert the 1 to 9/9 and add that to 40/9. And I think you're going to like how that turns out. That makes our work a little easier. So on the right side, we're going to have 49/9. Look at that, 2 perfect squares. We like that. On the left side, we need two numbers that add to -2 and multiply to +1. So that will be x minus 1 squared. And now we'll go ahead and we'll take the square root of each side. And since we have these perfect squares, we can do that. So now we have x minus 1 equals plus or minus 7/3. And when we isolate x and move 1 to the right side, we have x equals 1 plus or minus 7/3. So we can add the plus or minus to the 7/3. Okay, we can think of the 1. Again, 1 is going to equal 3/3. So we will have x equals, so 1 minus 7/3 would be -4/3, and 1 plus 7/3 would be 10/3. And those are our two answers. So now let's go to the quadratic formula. Let's see how well you remember this. Okay, number 15, x squared plus 12x minus 24 equals 0. So let's identify our A, B, and C. So our A equals 1, our B equals 12, and our C equals -24. So remember, it's looking for a place to write the quadratic formula. -b plus or minus the square root of b squared minus 4ac, and all that is over 2a. So there's the formula. Okay, so let's start making our substitutions. So x equals -12, so our b value is 12, plus or minus, we need a nice long radical. Use parentheses, please. 12 squared minus 4 times 1, and 4 times 1 and 4 times c, which is -24. Always use all of the numbers, even if they're 0 or 1. Don't just do it in your head. There's too many mistakes you can make when you do this, students. I would always recommend that you write everything out just like that. So let's start evaluating. We have x equals -12 plus or minus. So now we have the square root of 144 plus 96, and all of that is over 2. Continuing on, working within that radical sign, we have our 12 plus or minus the square root of 240, all that divided by 2, and that will equal plus -12, excuse me, I almost forgot my -12, -12 plus or minus, and we can think of 240 as 16 times 15. So, so that would be the square root of 16 is 4 times the square root of 15, all over 2. And I'm going to erase my quadratic formula so I have room for the answer here, which will be x equals. So I can divide the -12 by 2. So that will give me -6 plus or minus. And 4 divided by 2 is 2. And I still have that irrational square root of 15. And that is a final answer. Remember, you can divide, but you cannot add or subtract across the plus or minus where you have an irrational number, okay? That's the problem, is the irrational number. Okay, number 16, and our A equals -1, B equals -3, and C equals 9. So we've got a challenge here with these negative numbers, and you have to be so careful with these. Now, when we have a negative B value, because we have a negative B in the formula, it's going to make the 3 positive. So this will be 3 plus or minus the square root. And now in the parentheses, -3 squared minus 4 times -1 times 9. And all of that is over 2 times -1. And we'll start simplifying all of that. So we've got 3 plus or minus, and we've got our radical. We have 9 plus 36. And I hope you remember that when we have a negative in our numbers over here, if we have one negative, that means we'll end up with a plus sign in our radical. And all of that is over 2 times -1, which is -2. And let's keep going. X equals 3 plus or minus square root of 45 divided by -2. And we can think of 45 as 9 times 5. 9 is a perfect square. So x equals 3 plus or minus. So 45, the square root of 45, we're going to think of that as the square root of 9 times the square root of 5. And the square root of 9 is 3. And all of that is over -2. And that's pretty much our final answer. We cannot simplify that anymore. So our final answer, 3 plus or minus 3, the square root of 5, divided by -2. Okay, number 17. X squared minus 4x equals 9. We'll need to move that 9 over, and it will become negative. So we'll have -x squared plus 4x minus 9 equals 0. And our A, again, is -1. Our B is 4. And our C is -9. So we know we want to be careful with those. So x equals -4 plus or minus the square root of 4 squared minus 4 times -1 times -9, and all of that over 2 times -1. And let's continue to simplify. We have our -4 plus or minus, and that will be 16 minus 36. And notice we have 2 negative signs in addition to the subtraction. That means we're going to have still subtraction as we begin to simplify, and that will be over -2. And let's simplify that further to -4 plus or minus the square root of -20 over -2. And I hope you notice that at this point, when we see the negative number in the radical, we can go no further because there is no solution to this problem. And then number 18, we need to move x over. So we'll be subtracting x from each side. So that'll be a -10x, and we'll be adding 5 to each side. So that'll be a +5. So let's rewrite this problem as 3x squared minus 10x plus 5 equals 0. And our A value is 3. Our B value is -10. And our C value is 5. So let's start making our substitutions. X equals, we have a negative B value and a negative B in the formula. So that means our B will be positive as we make our substitution. So 10 plus or minus -10 squared minus 4 times 3 times 5. That's our AC. And all of that over 2 times 3. And let's continue on. X equals 10 plus or minus. And then we will have 100, -10 times -10, minus 4 times 3 is 12, 12 times 5 is 60. And in our denominator, 2 times 3 is 6. We'll keep simplifying. 10 plus or minus 100 minus 60 is 40. And we can think of that 40 as 4 times 10. So we'll think of the 40, the square root of 40, as the square root of 4, which is a perfect square, times the square root of 10. So we will have x equals 10 plus or minus the square root of 4 is 2, so it will be 2 times the square root of 10 divided by 6. And we can simplify that. Let's change our color here. We can divide everything here by 2. So 2 divided by 2 is 1, and that will become an invisible 1. 6 divided by 2 is 3, and 10 divided by 2 is 5. So remember, when you have an irrational radical, you can still simplify numerators and denominators. So that means our final answer is going to be, let's use our brackets. So we've simplified. So in the numerator, we have 5 plus or minus the square root of 10. And the denominator, we have 3, and that's our final answer. So you have some problems you can do for a little bit of extra practice. You could solve them now. If you want to send pictures to me, or if you're in person, show me pictures, and you can check your work. I'll check your work for you. Meanwhile, you've worked hard in quadratics, and I'm super proud of that. So just keep it up. You've got, about 8 or 9 or 10 days left till the end of the year. I'm so proud of how well you're doing. And as always, I say, with practice, you'll be great.